Well, good morning. Now that we've finished up section 8.1, which is the Pythagorean theorem lessons, we're ready to move on to other special triangle rules. This entire unit, entire chapter is about triangles and their special circumstances, all about right triangles to be more specific. So Pythagorean theorem, Pythagorean triples will work for solving for missing sides of triangles if they are right triangles and you already know two sides. Sometimes you don't already know two sides and you need more information, like angle measures, in which case you would have to use trigonometry. That's the last unit of this chapter, so that's coming up in section 8.3 later in the week. Between those two pieces, though, is a set of special right triangles that we use a lot in trigonometry, and this is the place where we learn about those two special cases. So we'll actually see those two special cases tomorrow and the next day in our notes. Today we're just going to set the stage for how to simplify the answers when we solve those. So we've got to go back and pull in some Algebra 1 lessons that we've not seen for a long time, and we have to deal with something called rationalizing a denominator. So, well, let me start with an example. Let's say, let me leave a little space here. We have a problem that says simplify 3 over radical 5. Now you'll note this is not a printed set of notes. You don't have a page already in your packet to take notes on for this one. So you could either take notes on your own paper, or you can print or use a digital copy of this when we're all finished. I will upload a scan of this page of notes, and you can refer to those scans as needed. So what does it mean to simplify 3 over radical 5? So we have radical form. We have a radical 5 that we do not want to put into a decimal form. What does it really mean to simplify it? So just to set the stage for this, I'm going to pull out my handy dandy CAS calculator that I use in statistics and show you what the calculator thinks about it. So I'm going to do fraction bar 3 over square root of 5 and see just what a simplified form looks like. Okay, so the simplified version is 3 times square root of 5 over 5. Now he might argue that doesn't look simpler. There's more stuff here than we had here. The reason we consider this a simplified form is because there's no radical in the denominator. And for reasons that some mathematicians actually argue over, this is considered a better version than this. I know when I teach trigonometry in my pre-calculus classes, often this form is more useful and will simplify down when you combine it with other pieces of information. So this, on a standardized test like the ACT, is the form that you will always be working with. So it goes without saying that we need to get it in this form. So the question is, how do we do that, and what is that form called? So let's start with a definition. Or maybe just a statement. The simplified form of a fraction, that's an N, always has a rational denominator. The process of simplifying is called rationalizing the denominator. Denominator. That shouldn't be that hard. Denominator. Okay, so fancy word for get the radical out of the denominator, or fancy phrase. So the goal today is to teach you the procedure to make the denominator a rational number, like 3 or 7, something that doesn't involve a radical whose decimal form is non-repeating, non-terminating. So how do we do this? Okay, so the process really is one step and then simplify. So the process: multiply by a form of 1 that contains the irrational part of the denominator. Then simplify. I almost didn't leave enough room there. And that's pretty general sounding at this point in time, so we really just need to see it to see how it works. So what does it mean to multiply by a form of 1? Well, in fraction world, a form of 1 is a number over itself, because anything divided by itself is equal to 1. So we want to take this irrational fraction, we're going to multiply it by something over itself that is equivalent to 1, a form of 1. And it needs to contain the irrational part of the denominator. Well, the denominator has a radical 5 in it, and that is irrational, which means I need a form of 1 that contains a square root of 5. The simplest form of 1 that contains a square root of 5 is square root of 5 over square root of 5. So you multiply by something over itself, it's always going to be the radical that was originally in your denominator. Alright, then simplify. Okay, that's the next part. So we're going to multiply these two fractions together. When we multiply two fractions, we multiply straight across. Numerator times numerator, denominator times denominator. Don't try to do this with your calculator. It's going to just convert everything to a decimal. That's not better. So this has to be done by hand. So across the top, 3 times the square root of 5. 3 times the square root of 5. The times symbol you can drop if you want. That doesn't have to be there. It would be an understood multiplication without it. In the bottom, square root of 5 times square root of 5. Both those 5s are under a square root, which means technically you have a square root of 5 times 5. So they can share the square root. Okay, 3 times square root of 5 on the top. I'm going to just drop that dot. You don't have to. The calculator, you noticed, has the dot there. On the bottom, you're going to go fish. So in the last chapter that we studied, the last section of study, we learned that a pair of numbers under the radical will come out. Square root of 5 times 5 is technically square root of 25, and the square root of 25 is 5. So the reason we're doing this process is so that we get a pair of matching factors, which makes a perfect square, 5 squared, and the square root of 5 squared is 5. So you'll notice 5 times square root of 5 over 5 is the same answer that the calculator gave us if we have a CAS calculator. You don't have a calculator with an algebra system built in, so yours must be done by hand. On standardized tests like the ACT, you will not have a CAS calculator. They're not permitted. You have to learn how to do it with pencil and paper. Okay, so this is our final answer. It looks kind of ugly, but once you learn the procedure, because it's just the same procedure every single time, it's just learning how to do a process. Okay, let's try another one. Number 2. Simplify 7 over the square root of 2. Okay, I know to simplify it I need to get the radical out of the denominator, so I'm going to multiply by a form of 1, and that form of 1 needs to have a square root of 2 in it, so square root of 2 over square root of 2. Then simplify. So across the numerator, 7 times radical 2, is 7 times radical 2. You can't combine those into a single factor because the 7's not under a radical, 2 is under a radical. Those don't combine. Keep those as separate factors. Radical 2 times radical 2 can share a radical and be radical 2 times 2. And then in the numerator we have 7 times radical 2. In the denominator, a pair of 2's makes a 2 squared, or a 4, and the square root of 4 is 2. So essentially, on the denominator, every single time we're going to end up with the number we started with under the radical. That original radicand is going to be no longer under a radical. So the number stays the same, it just doesn't have a radical on it. So 7 radical 2 over 2 is our final result. Some of you will, after 3 or 4 examples, start to see a pattern. And if you see the pattern and get the pattern, you'll be able to go straight from here to here without writing any work down. So if you're pretty savvy and you can see the pattern and test it and make sure it works a few times, use the pattern that you see. Okay, let's go to number 3. So simplify. We're going to throw an extra little piece of work in this one. Sometimes the simplifying takes more than just the one step. This is an example of that. I have a radical in the denominator. That means I need to multiply by a form of 1. Radical 3 over radical 3, because the radical 3 is what we're trying to rationalize. Okay, multiplying straight across, 6 times radical 3 in the numerator. Radical 3 times radical 3 in the denominator. Now if you're pretty savvy and you already know that's just a 3, then just go ahead and write a 3 there. If you need to see radical 3 times 3 again, you can keep writing it down. And then in the next step, 6 times radical 3, and a pair of 3's on the inside is worth a 3 on the outside. So we go straight to the 3 on the bottom. Now we aren't finished with this one because there's a new piece of work that needs to be done here that didn't exist before. In problems 1 and 2, 3, 5, and 7 and 2 are all prime numbers, and they share no common factors other than 1. So once we got the rationalization done, there was no additional simplifying that could be done. There is additional simplifying that can be done here. The 6, the whole number 6, and the whole number 3 have a common factor of 3. If you look at just the 6 over 3, that will simplify down. 3 will divide into both 3 and 6. 3 will divide into 3 one time. 3 will divide into 6 2 times. So we can simplify that fractional part further. That will give us a 2 times radical 3 in the top. And an understood 1 in the bottom. I can drop 1's in the denominator. So I end up with something that actually does look simpler than what I started with there. And this is the draw of using this process, is you can start with something that's a fraction, and oftentimes it will simplify to something that's no longer a fraction. Okay, so always look for factors outside the radical that can be simplified down before you quit. Let's try another one. Number 4. Simplify 2 over the square root of 6. Alright, multiply by a form of 1. So square root of 6 over square root of 6. And that's equal to 2 times square root of 6 on the top. On the bottom, square root of 6 times 6. If you already know that's going to be a 6, you can skip this step. So 2 times radical 6 over pair of 6's on the inside is worth a 6 on the outside. So square root of 6 squared is 6. Then 2 and 6 have a common factor of 2. 2 will divide 2 one time. 2 will divide 6 3 times. And that will give us a 1 times square root of 6 in the top. I can drop that 1 and just keep the radical 6. And then a 3 in the denominator. And that is simplest form. Alright, so the procedure is the same every single time. The only thing that changes is there may be more simplifying to do. Alright, so let's do some additional examples where there's more simplifying to do to make sure we have that process, and then we'll be done with the notes for the day. So number 5, let's simplify 15 over the square root of 3. Alright, so we're going to multiply by square root of 3 over square root of 3. I'm going to skip a step this time just to see what that looks like. 15 times square root of 3 in the numerator. In the denominator, square root of 3 times square root of 3 is going to be square root of 3 times 3, which is just 3. The reason we use this process is so that we get a matching pair in the denominator, and matching pairs end up being whole numbers. So it looks a little less messy if we can skip a step there and go straight to the whole number. Now I see a 15 over 3, and 15 over 3 is simplifiable because 15 and 3 are both divisible by 3. So 3 will divide 3 one time. 3 will divide 15 5 times. So in the numerator we have 5 times radical 3. In the numerator or denominator, an understood 1, we can drop that. So final answer is 5 radical 3. Okay, let's throw in another catch. So for number 6, let's do 2 simplify, some instructions, 2 over 3 radical 2. Okay, so now I'm going to throw in an additional factor in front of the radical. When you do the multiply by the form of one step, you can make your work harder or you can make your work as easy as possible. Don't work harder, let's work smart. We have a procedure. The process is to multiply by a form of 1 that contains the irrational part of the denominator. Well, the irrational part of the denominator is the factor radical 2. 3 isn't irrational, only the radical 2 is irrational. That's the only part we need to multiply by. The 3 will just carry along. It's not anything we need to worry about. So we're going to multiply by just the radical 2 over radical 2, not the 3. 3 is good. Okay, when we multiply straight across, 2 times radical 2, 2 times radical 2. On the bottom, we have this 3 that we need to keep up with. So let's bring it over. There's an understood times sign after that 3, so times. And then square root of 2 times square root of 2 is 2. So the only difference between what we're doing in this step, what we're doing in this problem and what we did in the one before, is we have this extra factor of 3 that we just have to keep up with. Okay, then I see, handy as it is, that I have a pair of 2's here and here that will actually reduce down. They'll cancel out. This 2 will cancel this 2. So just mark through those and let's bring over what's left. So nothing left in the top except this radical 2. On the bottom we have nothing left but a 3. So final answer is radical 2 over 3. You'll notice in all of these problems you still have a radical when you're finished. The radical never totally goes away. Once you have a radical, you always have a radical. It just moves to the numerator, and that's considered a better form than a radical in the denominator. Okay, let's throw in 2 or 3 more examples that have additional things floating around that have to be dealt with, just so we've covered all of our bases, and we'll call it done and let you get some practice. So simplify 12 over 9 radical 5. Alright, we're going to multiply by a form of 1. Only need the radical part. So radical 5 over radical 5. Don't mess with the 9. The 9 is rational. It's fine. Okay. In the numerator, we have 12 times radical 5. 12 times radical 5. In the denominator, carry over your 9 times, and then this pair of 5s, radical 5 times radical 5 makes a plain old whole number 5. Okay, be very careful that you don't try to cancel things inside radicals with things not inside radicals. This radical 5 and 5, they won't reduce down. Square root of 5 is 2 point something ugly. 5 is 5. Those are not equivalent. And you can't, in any of these steps above, a radical over a whole number, radical over a whole number, those never simplify down. Those are not equivalent. You can only cancel things that are equivalent. What I can do in this last step is simplify down anything that has common factors. 12 and 5, they have no common factors other than 1. 1's not helpful. But 12 and 9 have a common factor of 3. So let's cancel out the 3. So 9 will divide by 3 times. 12 will divide by 3 4 times. So we can simplify that fraction and bring over what's left. So 4 times radical 5 in the numerator, and 3 times 5, which is 15, in the denominator. Okay. It's not so much that it's hard work, but it is tedious. You have to be really careful to keep up with all of your factors. Okay, let's try a couple more, and we should have all the information that we need. Number 8, let's simplify 5 square root of 2 over square root of 6. Okay, so now this is a new puzzle. We've not had an example yet that had radicals in both the numerator and the denominator. So throwing an extra wrench in the works here. The rule is still the same. We're still going to multiply by a form of 1. And that form of 1 still needs to contain whatever radical is in the denominator. So we don't worry about the one in the numerator. The one in the numerator is okay where it is. It's that radical 6 that we have to fix. So we're going to multiply by radical 6 over radical 6. If we multiply straight across, we have more stuff to keep up with than we did before. We have the 5, okay, times. Now I have a radical 2 times a radical 6, and those can be combined under the same radical. So radical 2 times 6. 2 and 6 don't make a pair. You can't just pull those out yet. And then in the denominator, square root of 6 times square root of 6 is 6. So we've got a pair there. So the denominator is really pretty. Numerator is going to need some additional work. 5 over 6 outside the radicals, 5 over 6 will not simplify down. 5 is prime, and it doesn't share a common factor with 6. So the only thing left that could potentially be simplified is what's under the radical. And I noticed that 6 can be factored into 2 times 3. Up until now, most of what we've looked at has been prime numbers. But 6 will simplify some more, and I know that it has a 2 in it, so if I simplify it on down, I'm going to be able to pull out a pair. So I'm going to carry along my 5, and under the radical, bring your 2 over, and then the 6 needs to be rewritten as 2 times 3. We're going to factor it on down, and then just bring over the over 6 from the last step. Now, let's go fish. This pair of 2's is essentially a 4, and the square root of 4 is 2. So we can bring a 2 outside the radical. Okay, so we already had a 5. Now we're going to pull a 2 out with the 5, and then in the radical we've left behind a 3 over 6. Alright, radical 3 is prime. 3 is prime. There's nothing else we can do with that. We do have a pair of common factors now in the whole number parts, the whole number factors. 2 and 6 have a common factor of 2. 2 will divide by 2 one time. 6 will divide by 2 3 times. Simplify that down. And when we bring over the leftovers, we have a 5 times, we don't worry about the 1, radical 3, over, we have a factor of 3 left in the denominator. Okay, so since that one is pretty tough, let's do one more that is a little bit longer, like this one, so that you have a couple of those in your notes to look back at as you work on your own practice problems. The good news is the simplifying that we need to do in section 8.2 is a lot less complicated than what we're seeing here. For the most part, they're 1 or 2 steps. 9, last example, simplify square root of 5 over 7 square root of 10. Okay, same procedure we've been using all along. Let's multiply by a form of 1. In the denominator, the radical 10 is the irrational part. So multiply numerator and denominator by radical 10. Let's bring over what we have. Radical 5 times radical 10, they're both under radicals. So we'll just combine them under a common radical, square root of 5 times 10. Hopefully you can already see that 10 will factor down some more and have a 5 in it. On the denominator, bring over the 7 times square root of 10 times square root of 10 is 10. Okay. In the numerator, 10 will simplify more. We can factor it further. So carry on our 5. This 10 factors down to a 5 times 2. So I'm going to get a pair of 5s. I can go fish. On the bottom, 7 times 10 is 70. So I'll go fish. The pair of 5s will give me a 5 outside the radical. So we can rewrite the numerator as 5 times square root of 2 over 70. 5 and 70 have a common factor. They're both divisible by 5. Because 70 is divisible by 10, it must be divisible by 5 as well. So if I divide by 5, 5 divided by 5 is 1. 70 divided by 5, you might need a calculator for that one. So dig out your calculator, do 70 divided by 5. It'll go 14 times. So we have 1 square root of 2. I'm just going to bring over as square root of 2. I can drop any 1s that are factors in front of the radical. And then 14 is left in the denominator. So 2 over square root of 14 is our final answer. Okay, so I'm going to make a scan of our notes and upload it to your Schoology folder. So you can print it if you want. You can go back and look at it whenever you need to. For today's assignment, there's a 1-page, it's a puzzle riddle page in your packet. Your Unit 8 packet, page 9, is your work for the day. You may not have enough room on that page to actually work everything out. Some of these take a little more space than what you have on that worksheet. Feel free to just grab a scrap sheet of paper to do work on the side if you need to. And when you finish with the assignment, go to your Schoology and take the homework check quiz that just spot checks that work. Let me remind you that you also have Unit 8 packet in your Unit 8 folder, which is separate from your online coursework folder, the online folders that we're doing during these NTI days. The NTI day folder is separate. But in your Unit 8 folder that I originally posted in your Schoology, all of the answer keys for the packet are there so that you can check your work. Please check your work. If you have questions, email me, message me. I will get back to you as quickly as I can. Alright, hope everybody's healthy and hanging in there. And that's it for this time.